just had a great question about the homework, which was 25.03, question 6. And this was about relative risk. And the question actually says there are calculations here for relative risk. So in other words, the table shows actual relative risk. Now, in the past, you've had to take a table of just basic data and calculate the relative risk, looking at one category and comparing it by dividing it by other categories. And that's fine. But in this table, it actually shows you these are the relative risks. So the first thing I notice is you've got the blood alcohol content, which is 0. The first one is 0. Now, if it's 0, it means they've got no blood alcohol concentration, or at least not a measurable amount of blood alcohol concentration for certain age groups. So this is the relative risk based on the age of those drivers. So it says, table shows relative risk for being involved in a fatal car crash by both age and blood alcohol concentration. So the first one, they've got 0 blood alcohol concentration. So this is the relative risk regardless of alcohol. There's no alcohol in their system, and yet we know that we've taken the first one as a 1. What does 1 mean? That means that everything is going to be compared to this one thing here. So 1 is the relative risk of this person having accident. For example, if this one here was 0.5, it would mean they have half the probability of being involved in a fatal road crash. This one here, if this was, let's say this was a quarter or 0.25, it would mean they have a quarter of the probability of being involved in a fatal road crash. So this is 1 though, and everything is now therefore related to 1. So if this is 1, this means that this person in the age group of 20 to 29 years old with no alcohol in their system has still 3 times the probability of being involved in a fatal road crash. This one here, because these are, and this is the important thing, these aren't numbers of drivers involved. These are, in fact, the relative risks of being involved. So that means this person has, if you're in this age group here, whether or not you have any blood, in fact, if you have no blood alcohol, you have 3 times the risk of being involved in the fatal car crash. These people, these young people, and it's a terrible thing, that young people are involved more, probably due to inexperience, 5.3 times the probability of someone who is 30 or older in a fatal car crash. So it's a terrible statistic. But that 1 basically means that everything now is related to that datum there. And there's nothing less. That is the datum. That is, if you like, what we would call the benchmark. Everything now is related to that. And so you can say, for example, here, we know that if you're in a 30 plus years age group and your blood alcohol concentration is 30, that's 30 milligrams of alcohol per 100 milliliters of blood, you have 2.9, nearly 3 times the probability of being involved in a fatal car accident, road accident, than you have if you had no blood alcohol at the same age. So that's what those things mean. So it says, how does the table show the calculated risk is made in relation to the sober driver? Sober, of course, meaning a blood alcohol content of 0, age 30 years plus. Well, the answer is they've used 1 as the datum, and or as, if you like, as a benchmark. That is basically our 0 point, if you like. Everything is going to be relative to that number there. And that's how they've done it. That's how they've shown it's in relation, by making that person 1 and everything else in relation to a number of times of that 1. So 3 times and 8.7 times and 16.5 times and so on and so forth. All right, so that's number 1. Okay, good. So that's the answer I would give there. It says estimate the relative risk, this is B now, at all age levels for a driver with a blood alcohol content of 50 compared to a blood alcohol content of 30. So because these are already relative risks, I'm not having to so much calculate the relative risk as just compare the relative risks. Because these are relative risks, I'm just going to compare them. So how do I how do I compare them? And it does say compare here. So there's nothing here for me to actually so much calculate as I'm just going to add up these numbers here. I actually done that on a separate table. Here we go. I'll try and draw this back just a little bit so you can see. I went ahead and drew this table up. I got a bit carried away. I put a total down the bottom here as well. But here's the same table. And I've got my 30 table compared to my 50 table. And all I've done here is I've created a total for the 30 blood alcohol content, or 30 milligrams per 100 milliliters of blood. And the total there, just adding these up, is 26.6. The total for having a blood alcohol content of 50, adding up the 1, 2, 3 different age groups, just adding them up. And one thing we don't know here, of course, are numbers involved. So, there's nothing to calculate. We don't have to do relative things by saying, but there's more people in this group or less people in this. We don't have to do that. This has been done for us by the fact that these are relative risks. So all we have to do is add these up and total them and then compare this by that. And that's what I've done here. And I've said, and I haven't done this very well, by the way, this is the probability of the 50 group. This is the 50 blood alcohol content. And over here is the 30 blood alcohol content. And I've basically said, look, if you've got a 30, oh wait, I lied. Ignore that, that's 50, this is 30. Crikey, doing it on the fly is not good. So what I found here is if you have a blood alcohol content in all age groups, it doesn't matter what age group you are, if you take the combined age groups, that your blood alcohol content is going to be about twice what your relative risk of having an accident is twice what it would be than if you were in the 30 BAC group. Or you could have this the other way around. You could say it's 26.6 over 53.6, and that's going to equal roughly a half. In fact, let's calculate that so I can say it definitively. What would that be? So you've got 26.6 divided by 53.6, and it doesn't matter which way around you state it. Right, so 0.496. 0.496. So we can now state that the actual relative risk is going to be half if you have a blood alcohol content of 30 compared to 50. You have half the probability of being involved in an accident overall. And it's the overall thing we have to state here. So overall, that's what that means. And the overall statement is what you should include. Anyway, that's how I would answer that. Hopefully that makes sense. And that's how I came to those conclusions.